hope you all are doing great. Welcome back to our YouTube channel, The Engineering Projects. Along with multiple wireless communication and processing features, ESP32 also offers some low power modes. When we power on our ESP32 module using a live power supply, then there is nothing to worry about the power consumption and power management. But in some applications, it is required to power up ESP32 module using a battery source. In such cases, the power consumption and power management plays an important role for longer battery life. So in this tutorial, we are going to explore various power saving modes offered in ESP32. These are the various power modes supported by ESP32. First one is the active mode. In active mode, all the Wi-Fi, Bluetooth, radio, peripherals, processors, RTC memory, timers remains on all the time. So this mode consumes most of the power, and the power consumption is around 260 milliampere. In some application, we do not need to enable the Wi-Fi and Bluetooth all the time, so we can disable these modules. When we disable Wi-Fi and Bluetooth, ESP32 enters into Modem sleep mode and power consumption is reduced to 20 milliampere. Next is the light sleep mode. In light sleep mode, the main processor is also disabled and it will wait for an event or some timer or interrupt to wake up from the sleep mode, and all the data will be retained when the processor will wake up. Next is the deep sleep mode. In deep sleep mode, everything is disabled except the ultra low power coprocessor and RTC. So in this mode, the power consumption is reduced to almost 10 microampere. Next is the hibernation mode. In hibernation mode, even the ultra low power coprocessor is disabled and only RTC remains active. So in this mode, power consumption is almost negligible, but we cannot retain the data when ESP32 wakes up from hibernation mode. ESP32 offers 8 kilobytes of static RAM to store data on RTC. Next, we have this print wake up reason function, in which we are using this switch statement, which is responsible to print the reason which caused ESP32 to wake up from deep sleep mode. It could be an external interrupt, some timer, or due to touchpad, or due to ULP coprocessor, etc. Inside this setup function, we are initializing serial communication at 115200 baud rate. This boot count will increase by 1 every time ESP32 wakes up from deep sleep mode. Here we are calling this wake up reason function, which we have defined earlier. Here we are enabling the timer to generate a wake up event for ESP32, and this function is using these two parameters as arguments. First is time to sleep and then the conversion factor, that is for 5 seconds. Next we have this serial.flush, which is responsible for clearing the data that has been shared over serial port. This ESP sleep start function is used to enable the deep sleep mode, and once it is enabled successfully, the next line will never be printed. So that's all about the code description. Now we can upload the code into ESP32 development board. Click on this icon and make sure that you have selected the right development board and COM port. Now once it is uploaded successfully, open the serial monitor and press the enable button. Make sure you have selected the right baud rate. Now you can see this boot number is reached at 3 and wake up caused by the timer. So again it is going to sleep mode, and after every 5 seconds a wake up interrupt will be generated. So that's all about the tutorial. We hope you found this of some help, and also hope to see you soon with a new tutorial on ESP32. Till then, goodbye.